Hello, my name is Stephanie Avalos, and I will be presenting the Marketing Campaign Analysis Project low-code version. The presentation will be divided into two segments. First, I will address milestone submission, which focused on data exploration and coming up with plausible data analysis models. And secondly, I will discuss the final submission, which includes a definitive model and its justification. Solving the problem of accurately segmenting a diverse customer base is one of great importance for a marketing team. It enables targeted marketing campaigns, improves customer engagement, and ultimately increases revenue. By accurately segmenting a diverse customer base, we can tailor marketing efforts, leading to more personalized interaction and higher conversion rates. This targeted approach not only boosts customer satisfaction and loyalty, but also maximizes the efficiency of our marketing resources, resulting in significant financial gains. The primary goal of this data analysis project is to improve customer segmentation for targeted marketing, enhance engagement, and increase revenue. We have also set some specific goals like increasing annual sales by 10%, reducing marketing campaign costs by 20%, and improving customer satisfaction and retention through personalized offers. Other possible outcomes are reducing the attrition rate and improving the lead conversion rate, which measures the percentage of users who take desired action out of the total number of visitors. By achieving these objectives, we can significantly enhance our marketing effectiveness and drive substantial business growth. When defining a problem, we must first explore the key questions that we aim to answer. For this project, we will be exploring the following questions. 1, which is the best modeling technique for customer segmentation? 2, how can the marketing team employ the data to support targeted strategy efforts? And 3, how can the understanding of demographic and behavioral profiles make strategies more impactful? These are the 3 questions that I aim to answer throughout this presentation. It is important to note that data science techniques like clustering and predictive analytics enable precise segmentation and insights. This drives personalized marketing and optimized resource allocation. It is this understanding that led us to select the different modeling techniques that we will be discussing later on. It is also relevant that clustering and segmentation allow us to leverage tools to tailor to our specific customer groups. Thus, we leverage unsupervised learning techniques to identify patterns and group similar customers for targeted marketing strategies and business decisions. It is relevant to note that our data set comes from a marketing campaign, capturing various aspects of customer demographics, engagement, and spending behavior. The key variables in our data set include year of birth, education level, and marital status, annual income, number of children and teenagers in the household, enrollment date and recency, spending amounts on wine, fruits, meat, fish, sweets, and gold products over the last 2 years, number of purchases made through different channels such as deals, web, catalog, and stores, number of website visits in the last month, response to 5 marketing campaigns and the most recent one, customer tenure, total accepted campaigns, age, and total purchases. From our exploratory data analysis, we observed several key patterns. Demographics show that most customers are middle-aged and highly educated. Spending behavior indicates high expenditure on wine and meat products with moderate spending on fish, sweets, and gold. Engagement levels vary, with some customers making recent purchases and others not engaging for a long time. Web and store purchases are the most common, while catalog purchases are less frequent. Campaign responses reveal low overall acceptance rate, but certain segments show higher responsiveness. Customers who accept campaigns also tend to spend more time and engage more frequently. We perform several pre-processing steps to ensure our data set is clean and consistent. We handled missing values by inputting the median, particularly for the income column. Irrelevant columns such as the ID column were removed. Dates were converted to date time format to calculate customer tenure accurately. We identified and treated outliers in income and spending related columns to maintain data quality. Feature engineering was done to calculate additional features like age, total purchases, total accepted campaigns, and days with the company. Finally, we standardized and normalized numeric features to improve the performance of our machine learning models. These steps prepared our data set for generating actionable insights, which will help us to optimize our marketing efforts. After exploring the data, we moved on to testing different models or techniques to solve the problem. We explored Gaussian mixture model, GMM, k-means clustering, and hierarchical clustering. Ultimately, GMM was the model we selected, which required some fine-tuning. We adjusted the number of components by experimenting with different numbers of clusters to find the optimal segmentation. We tested different covariance types to see which best fit the data, and we improved the model stability by trying different initialization models. In regard to performance performing comparison of the different techniques, we chose the metric of silhouette score. This metric was chosen because it measures how similar a point is to its own cluster compared to other clusters, providing a clear metric for cluster quality. The score ranges from -1 to 1, where higher values indicate better defined clusters. And in this case, it was particularly useful in understanding the cohesion within the clusters and the separation between them. As you can see on the table on the screen, each of the models has a score and pros and cons. Due to time constraints, I will not spend too much time on it. I will say though that the GMM model achieved a higher silhouette score of 0.58 compared to k-means clustering with 0.45 and hierarchical clustering with a score of 0.41. Since the best performing technique is the Gaussian mixture model, I will be mentioning that the GMM's flexibility in handling different cluster shapes and sizes, along with providing probabilistic assignments, makes it more effective for this complex structure of data. To further enhance the performance of this model, we can also implement some additional improvements, such as feature engineering, model tuning, data enrichment, cross-validation, and advanced techniques like DBM scan for detecting outliers or assembling clusters to combine the strengths of multiple algorithms. In summary, the comparison indicates that GMM outperformed other techniques based on the silhouette score. Even though GMM is computationally more intensive, but it is flexible and probabilistic. So the improvements through feature engineering, model tuning, and data enrichment can enhance the performance even more. So performance-wise, as mentioned previously, GMM had the highest silhouette score. In terms of interpretability, GMM provides cluster assignments, offering deeper insights despite being slightly more complex than the other two models. And so once we selected that model, we did find that there is 5 clusters that from the data that are worth spending or giving more attention to. There's the high spending cluster, which is a customer base that has high income and spending, primarily consisting of larger families. A moderate spending cluster, which includes customers with moderate income and spending, generally consisting of smaller households. Low spending cluster that have lower income and low engagement, indicating a need for re-engagement strategies. There's a family-oriented cluster characterized by moderate income and higher spending. On family-oriented products, this segment consists of larger households with children and teenagers, for the most part. There's also a high engagement cluster. This group shows high engagement and responsiveness to campaigns with moderate to high income and spending. Understanding these segments allows us to develop targeted marketing strategies that optimize resource allocation and improve overall customer engagement and revenue. So some specifications for the model is that the number of clusters is 5, as previously mentioned. The covariance type is full. The initiation model is k-means, and the random state is 1. Some key next steps after determining the model are deploying the GMM model on a cloud platform and integrating it with a CRM and a marketing system to leverage more data, to develop and launch targeted marketing campaigns for each identified segment, to continuously monitor data quality and update the model to maintain accuracy, and to explore additional features and external data sources to refine the segmentation. For these next steps to occur, we also need to consider some requirements involved for the stakeholders. For example, for the data team, it is important to ensure ongoing data quality, manage the data pipeline, and handle real-time data processing and feature engineering. For the IT and development team, it is important to deploy the model on a cloud platform, integrate it with a CRM and marketing systems, and maintain the infrastructure. For the marketing team, it is important to utilize the customer segments generated by GMM to design and execute targeted campaigns. And of course, to monitor that performance. And regarding the management team, it is important for this group to oversee the project, ensure alignment with business objectives, and allocate necessary resources, as well as monitoring progress. By following these steps, stakeholders can maximize the benefits of the model. So the GMM is a valid solution because it addresses the core challenge that we had to segment the customer base with a high level or high degree of accuracy and flexibility. And it relates to high cluster quality, the fact that it provides detailed insights. It is also flexible in modeling clusters. It allows for resource optimization. It enhances marketing effectiveness by tailoring campaigns, and it supports strategic decision-making. The expected benefits and costs are also an important part of making the decision of which model to employ and overall which one makes more sense for the business. In this case, the benefits include increased revenue, a projected increase of 10% in annual sales, translating to an additional roughly $500,000. There's some cost savings as well, a projected 20% in reduction of marketing costs amounting to about $100,000 annually, improving customer engagement, and resource optimization. The costs associated are estimated at $50,000 for initial setup costs, covering cloud services, software licenses, and integration fees. Ongoing maintenance costs are estimated at $10,000 annually to support the updates. There's some training costs as well, estimated at $5,000 for staff training on using and interpreting the GMM model. There's also some key risks and challenges to consider, particularly ensuring high quality, up-to-date data, integrating complexity, guaranteeing that the CRM and marketing systems can integrate with the data being used for the model. And this will probably require significant IT resources and time. There's also some requirements in model maintenance. These ongoing updates are necessary to keep the model accurate and relevant. So that requires continuous investment. It's also important to train and maintain technical capacity within the team, ensuring that the marketing and IT teams are adequately trained to use the model and interpret the results. By addressing these recommendations and considerations, stakeholders can effectively implement the GMM model, maximizing its benefits while mitigating potential risks and challenges. Important to note that this summary that I've provided now in this presentation comes from a full report that includes more detailed information on what I've just mentioned. It also corresponds to the prior coding process, which led us to these results and which really provides the richness of the data for the clustering. And with that, thank you for your time.